Sounds
Yes.
good. All right. Well, it's 9 o'clock. We're going to get started. Hopefully, everybody is on. I want to be respectful of all of your time. I want to welcome our newest addition to the region, our Detroit friends. For many of you who don't know, Detroit was recently added to my portfolio, and I'm quite excited to do the work that I'm doing up there. This series has been designed to bring you the brightest and greatest from the Technion. Beni happens to be one of my favorites out of all of them that I've met, so I'm excited to interview him. It's going to be a question and answer type interview. And if you guys come up with any questions out in the audience, please type them in the chat and we will address them when we get to the end. Just to give you a little background on Beni, he runs the Turbo Machinery and Heat Transfer Lab at the Technion, and he has 30 plus researchers and students from 10 different countries working for him. Beni is not Israeli born. He is actually from Turkey. He studied here in the US at Purdue, where he got his master and doctoral degrees in mechanical engineering. During his PhD studies, he also conducted research at the Von Karman Institute for Fluid Dynamics in Belgium. Finishing his studies in 2012, at 28, he made Aliyah to Israel, made Aliyah, and he joined the Technion. He became the youngest faculty member in Israel, the whole country, and since then, he has served in the department in the Faculty of Aerospace as a vice dean for research, and has been involved in a lot of the committees around campus and in that faculty. Some of his accolades are the Uzi and Michael Halevi Award for Innovation or Innovative Applied Engineering at the Technion in 2018, and the Henry, I'm going to mess this up, Gutworth Prize for Promoting Excellence in Israeli Research Fields back in 2017. There's a ton more that we could mention, but I'd love to just dive into this and get started with him. Just so you know, he's published over 40 times, and he is recognized worldwide. I have spoken to others at the University of Michigan, people here at Case Western Reserve, and when I bring up his name, he is known. So welcome, Beni. We're so excited to have you.
Yeah, thank you very much for the very kind introduction. I'll try to live up to the expectations.
There you go. So let's dive in. Of course, the first question on everybody's mind is how are things in Israel? I know we were talking about it a few minutes ago, but if you could tell us what's going on, how the year has been, things along those lines, just for a minute or two, that would be wonderful.
Yeah, the last, year, as you know, year and a half now, it's been quite turbulent. A lot of ups and downs, a lot of unexpected surprises, both basically nationally and also in terms of the modus operandi of Technion, because it's very difficult, I think, as an organization, both in terms of education and research, to be able to adapt to the ongoing changes at all times. I can talk a little bit about my own personal reflection on the
Please.
subject, that I think as a researcher, it's very, very difficult in order to be able to basically continue doing research and continue doing some of your activities, a lot of them funded activities, in a setting where you really don't know if tomorrow there's work or if there's some emergency mode, or the suppliers are going to deliver the goods. It's just a really big disruption in the usual way that things are done, and it's been very turbulent. Now, personally, less on the professional side, I believe in statistics. So when I look at the rockets that are raining, if you look at it, it's very unfortunate, the losses and the casualties and the injured. But statistically, in a population of 10 million people, the likelihood of me getting killed in a car crash are greater than being killed by a rocket.
Right.
So that's, I guess, the perspective of a nerd engineer looking at things in a slightly less emotional way. But of course, my wife thinks very differently than me. So
of course. Well, and for those of you who didn't hear Beni and I talking before, Beni's a brand new father. He just had his first son who's 6 months old. So
yes.
I think I understand your wife's perspective. Uh,
I do as well.
yes.
And hence the black eyes underneath that are permanent, right? It's like I do two shifts here, one shift at home, so it's just the days blend.
I remember those days, very long time ago for me. So um, great. Thank you for all of that. Regarding your research, one of the things that we're trying to accomplish through everything that we do here at ATS is to help our constituents understand not only why it's so important to help us support ATS or the Technion, but we'd like to hear from you why researchers like you choose the Technion, why it's so important to you to be doing your research there.
Yeah, I think this is a very multifaceted issue as well. I mean, for me, it was more of an emotional decision rather than a uh, logical decision. I grew up in Turkey, in Izmir, and in a very Zionist family. And I always tell the story in this way, and it's 100% true. When I was a little kid growing up in Izmir, it was my dream to be a faculty member in Technion.
Wow.
And the moral of that story is be careful what you wish for. It might actually come true because I came here and there was a big discrepancy between my expectations and reality and the whole adjustment period and all that. But I'm nevertheless very much privileged to be here. Um, let's be honest. I mean, besides in our faculty, in our department now in the aerospace engineering, we have a number of, um, let's say, internationally educated faculty members that are also not Jewish that have chosen our department because of the academic excellence. I think this is also a very important point to make because if we are just choosing a certain place just because of our emotional reasoning, this is nice, but it actually shows something when others choose to be a part of this journey because they actually like what they see in terms of their academic portfolio. And we have also that. So we have actually
Right.
three faculty members now that are no relationship to Israel. They are very much impressed with the work being done here and contributing to the education and research here.
Okay. All right. Bear with me for 1 second. I had somebody looking for the link. I'm sorry about that.
No problem.
Um, Tell us a little bit about your life before the Technion, being in the States,
Yeah.
Purdue, all of that.
I loved it. So when I went to college at Purdue, so I got my bachelor's, master's, PhD, the whole shebang at Purdue. I loved it. I really enjoyed a lot my time there. I made some of my best friendships there. We still get together with basically my fraternity brothers on a yearly basis after so many years. It's
Nice.
been so long.
Yeah.
I loved my time there, and I also loved the the educational atmosphere there. I think I learned personally a lot in terms of scientific education, not just the material, but also the work ethic, the discipline, the way what is expected from you, how to actually conduct research philosophy. All of this, I mean, all of this, it seems obvious to a lot of the US educated people, but this is actually the cultural difference that you see between the Americans and Israelis and all the other, let's say, Middle Eastern nations, right? So I think it was also very important for me to be uh, get exposed to that. And also now in our department, besides from me, there's actually a number of other researchers that are also all, let's say, US educated, and they have also very similar mentalities on how scientific research should be conducted and education should be conducted and all that. So we consider ourselves the representatives of the American educational system in Technion.
That's interesting. That's interesting. Well, it's as I've talked to you and others at the Technion, and then I talk to your counterparts here in the U.S. I'm always amazed, especially the first time I meet them. The thing I get is, can you send me 10 researchers from the Technion? Because quite frankly, the focus of these students and associate professors and everything is just so much different than what we get in the US here. So I find that to be extremely interesting. Well, let's
I,
dive into
I, I think you're right, by the way. I
yeah,
think that at every level, the peak performers of Technion are on par, and if not better, than majority of the people that you would encounter in US institutions. So really the academic islands of excellence are representing true excellence,
yeah.
not just
Do you attribute that to, the age that they enter into the institutions? In the US, we start at 18, as you know. But it seems like over in Israel, people are in their mid to late 20s when they get started.
I think it's values. I think
Okay.
it's hard for me to say, right? Well, I'm not a sociologist, it's not my field,
Right.
but I think that people do things because of true passion, whereas a lot of the students and also faculty in the States make financial decisions that dictate their direction.
Okay.
And there's reasons for both, right? There are societal reasons for this also. But I truly think that what I see, at least the excellent students and faculty members and researchers in even in the industries, they do it because of the passion, out of passion for what they do,
Ah, I love that.
passion
I
for
love that.
impact, passion to develop society, everything. Yeah.
Great. Well, let's pivot a little bit. I want to dive into the work that you're doing. Tell us about your lab and the, 30 plus individuals you're working with and
Yeah.
some of the things that you're working on, things along those lines.
Yeah, sure. Um, so we're the Turbomachinery and Heat Transfer Laboratory. So I came in here at around 2012. I became actually officially the head of the lab in about 2016, I think. And since then, basically, we started doing more and more active research, industry-funded research, both nationally and internationally. So we get actually around 60% of our contracts from abroad. Only 40% of our research grants come from Israel. And I had the privilege to start adding more and more people to the research team. And what sets us a bit apart from many of the other academic labs is that we we are able to do research all the way from basic science to very much applied, basically engine demonstrators. So we can actually start a technology saying, hey, we have an idea, whether it be a thermodynamic cycle project or an idea on how to do noise cancellation and all that, and we propagate that all the way to an engine demonstrator, which is, I think, somewhat unique in an academic setting.
Interesting.
And one of the reasons that we are able to do that is because through the years, we have amassed a number of engineers and scientists that are complementing the students and being able to carry the knowledge from generation to generation to generation rather than rebuilding every time
Time you get a new
as you lose
student.
a
Yeah.
student. Exactly.
Yeah. So,
So we're basically trying to bridge this gap of lack of a national lab in Israel by containing that knowledge in our laboratory.
okay.
So in terms of some of the projects, I can actually proudly say that we had, for example, a project on how sound waves can influence, for example, the fluid mechanics of the flow in a pipe or flow in an airfoil surface. I mean, it was a very fundamental basic science project that we started. And then eventually we patented this new application of flow control, of reattaching flow over surfaces by using sound waves, and use it in heat exchangers. And now we have just finished a project with US Air Force on how to, using the exact same technology, how to prolong the altitude ceiling of platforms so that these UAVs can reach higher altitudes. And
Okay.
now that we're finished that, we're actually about to do a full turbine demonstrator that incorporates this technology. And that's basically what I'm talking about in terms of the TRL growth or technology readiness level growth, right? You go from a concept to a scientific demonstrator to an engineering demonstrator, all the way to a proof of concept demonstrator.
Will that
So
turn into an eventual large scale manufacturing of something?
Not here, right? So that's where the academia and essentially in this in the span of TRL, technology readiness level, TRL 9 is a product.
Okay.
TRL 6 is a technology demonstrator. So we try to grow it from 1 to 6, and anything after 6 is any commercial entity needs to actually take it upon themselves, whether it's in Israel or abroad and all that.
Okay. All right.
So
So tell
that's kind of the vision. Yeah.
Yeah, no, I get it. Tell me, I know one of the things that you're big in is noise cancellation when it comes to engines and things along those lines. Tell us what that's all about.
Yeah, that's actually a strange concept that we started working on a number of years ago. The basic idea is, what if we can make sound not from vibrations of a surface as we are used to, it's vibroacoustics, but what if we can make sound just by small temperature oscillations of a surface?
Okay.
So the basic idea is, in a gas turbine engine or in an airport, right? We get a lot of noise. A lot of the noise comes from actually the exhaust of the engine. So if I could, just like I have these speakers, if I could create equal in magnitude and opposite in phase noise, right? I could completely annihilate this noise by destructive interference. So
Hmm.
then why don't we? The reason is, at the exit of an engine, you cannot just put a bazillion little speakers to create the opposite noise, the anti-noise, to get rid of it.
Okay.
So what we started working on is a technology that we can put inside an engine, which makes sound not by vibrations, not by physical pushing of the air, but it makes sound just by small changes in temperature by passing some electrical circuit and some currents across it. So this is actually called thermoacoustic interaction in physics, and we've actually developed some new materials and new thermophone transducers that make sound without any physical motion. It's a stationary object, just makes sound. It can make polyphonic sounds. So you can literally pass some modulated electrical current through it, and it can sing whatever you want. So we are now depositing these surfaces on turbine blades and fan blades in order to create destructive noise cancellation, which is this anti-sound. And we are able to cancel the tonal noise that comes out of a fan. And we've already demonstrated this.
Very interesting. So can you speak a little bit to how it would work? I mean, you kind of did in commercialization for, at the airports. I'm imagining that militarily it could also have some great applications.
Yeah, 100%. So this is, I mean, almost everything that we do in the lab is dual use. And I think we we pay particular attention in order to make sure that it's dual use.
Okay.
Because at the end of the day, Israel, we have to also look after the national needs, both in terms of the societal impact as well as the defense impact. So that's
Yeah.
why you can only focus your energy so much. So that's why we want to make sure that we cover both bases. And this for sure can have applications for airport noise regulations, but as well as it can applications for unmanned aircraft that has stealth needs.
Right.
So you can actually literally flip a switch and it would allow you to have on-demand noise cancellation when you need it, where you need it, and then you would just flip it back off when you don't need it, and then you don't need to waste the energy that you would use to actually have that self.
So it's funny. I just got done watching Top Gun and Top Gun Maverick, and that
Yeah,
you hear the boom of the engines as they take off, and I'm
exactly. The
imagining that
roar.
right, which would be pretty cool. It kind of stops people from hearing it coming, so to speak. That's really interesting. All right, so let's move over to because this one really fascinates me, a coin-sized turbo generator. Because when I think of a generator, I think of this massively huge thing. So tell me
Yes.
about this and what it means in applications and things along those lines.
Yeah, this is actually a very interesting challenge. So when when we're thinking about small engines in various applications, people have tried to figure out energy supply systems for, small drones, multicopters that are flying around. And when you try to actually take essentially internal combustion engine, or if you try to take a fuel cell or batteries, all of these applications are very, very heavy, and they actually limit the flight time of the platform because they're so heavy. Their energy density is not so much. So what we have tried to do is to be able to design a small gas turbine engine that's literally 2 inches in scale
Wow.
that can convert the energy that's trapped in the chemical bonds of the fuel into shaft power and then electricity in order to be able to prolong the flight time of the platforms. So now the obvious question that one should ask is, why would a gas turbine provide longer endurance flights compared to a platform that takes off with batteries, for example?
Okay.
So in terms of units, the best battery in the world today has energy density of 0.5 megajoules per kilogram. Whereas any fuel, your favorite fuel, pick hydrocarbons, jet A, diesel, gasoline, whatever you want, around it has 40 megajoules per kilogram. So that means the factor of energy density, so in that 1 kilogram of fuel, the amount of energy that you have is 80 times more in fuel than it is for batteries.
Wow.
And that is exactly why every single large aircraft today flies with fuel. This is the reason why, right?
Okay.
So now the challenge here is, how do you convert the energy in these chemical bonds into electricity in a system that is extremely compact? And this is actually the real challenge. And then this is where you compare different type of generators, whether it be a gas turbine generator or internal combustion engine or a fuel cell and all these things. So fuel cells are extremely heavy. For flying applications, they have almost no prospect because they are very, very, very heavy technologically. They might be very good for ground power generation applications one day, but not for flying stuff.
Okay.
So between the internal combustion engines and a gas turbine engine, the gas turbine engine technologically has an advantage. The advantage comes from the fact that we have a continuous cycle. So if you think about your car engine, it has around, even if you have a high performing car, it operates as a cycle of around 10,000 revolutions per minute, right? This is roughly your indicator in the car indicates around 10,000 RPM. So these small gas turbines that you see, they operate up to 500,000 RPM. So exactly because of this speed difference in between the cycles that we're introducing, we can make the generator much, much more compact in a gas turbine than it is with an internal combustion engine. So this is actually one of the starting points that we had when we initiated this project. The next phase for us was to try to create a gas turbine that works at these scales. So this is actually a
Right.
challenge on its own. So I like actually science history a lot. So there has been previous efforts to make compact microgenerators, but they have all failed, including in places such as Stanford, in MIT, in a few places actually in Asia, as well as in Belgium, where I was doing some research in Von Karman Institute. And the reason that all of these efforts have failed is mostly because they try to take the design guidelines that are for large engines and apply it to small engines, just miniaturize the whole thing, right?
Okay.
But this is the wrong, well, it's not really wrong, but this is now in hindsight, we can say that this is the wrong design approach. So what we have done is we have created models that capture the physics of not only the aerodynamics and thermodynamics that is taking priority in large engines, but also we have considered models that take into account the heat transfer, manufacturability, rotor dynamics, vibrations, the bearings, combustor, and all of them. And we have created a system level optimization that takes into account all of these different factors and ended up with this strange geometry that we are working with today. And this has allowed us to be able to actually show a working engine at this scale.
That's amazing. So you're going to revolutionize how engines and energy in engines take place.
Yeah, I mean, I would say our goal is to, I would agree with that statement. Our goal is to make a revolution in low power output generators for propulsion and power generation applications. So it can be for compact power generators. You can think of it like you go camping. Instead of taking this giant battery pack or a very noisy, large IC engine, you take a tiny little,
That's
exactly,
incredible.
with the
Yeah,
fuel, like this size with the
right.
fuel. You understand? And then basically it would be able to power up your whatever for 2 hours, 3 hours, no problem. So
Fascinating.
and the gas turbine business is a very interesting business because all of the major industries today have been founded by essentially two guys. Frank Whittle, who was the founder of the gas turbine engine in the very first inventor of the gas turbine engine in Britain, and Hans van Hoyen in Germany. And these
Okay.
two guys essentially seeded the design and the analysis approach of all the big OEMs, original engine manufacturers, all across the world. Rolls-Royce, GE, Honeywell, whatever.
Right.
So the way that we are perceiving ourselves is it's as if once again 1939, and as if we are restarting the journey of how to design a gas turbine engine just from the first scientific principles and not actually go through the exact same pathways that everybody else has gone. And I think this is why we had some limited success, because all of those perspectives are very good for a certain type of engines, but not for a different type of engine.
Fantastic. So one of the things that you're working on that I just find fascinating, and I was sitting with someone yesterday who happens to be listening in today, we were talking about 3D printing. So, we think about 3D printing, it's a machine that's about this big and it creates these little plastic things. You think about 3D printing and you're talking about, airspace engines and all of that kind of stuff. So I think our audience would find it fascinating to hear about not only the printer and how large or small or whatever it is, but what's coming out of it. My understanding, and please, I may be wrong, is that it's pretty much a solid one-piece unit that's coming out of it. So fill us in on that.
Yeah, around 5 years ago, we started taking design for manufacturing as a research direction. So that's why we incorporated in our lab a 5-axis CNC and a lathe and a grinding mill and all that. And then eventually, one of the things that we realized is the next phase of this development is looking into additive manufacturing rather than subtractive manufacturing, which is well established. In terms of additive manufacturing in the lab, we have right now 3 different technologies. One of them is a metal laser printer. It's called powder bed fusion. So we start with a powder, very fine 50 micron grain size powder on a layer. And then we actually have a laser that essentially solidifies by a melt pool process, solidifies the powder layer by layer in order to make functional parts. For example, this part that you see here and this part that you see here, they're both made from this particular printer, from this particular process.
Okay.
And these are functional parts. If you actually do a design for manufacturing, rather than just using this as another, as if it's a CNC machine. You make the design such that it's manufacturable with powder bed fusion. You can actually get fully self-supported parts that are 3D printed, and they're functional. These are made from Inconel 718. Inconel 718 is what's called a space alloy. It has very high strength and it can sustain very high temperatures. And the combination of the two is very, very important, especially in gas turbines where you have combustion and this thing spins relatively fast. So it has a lot of forces that are applying on it, right? So this has been the journey in one aspect. On another aspect, we started working on ceramic additive manufacturing. So using a similar layer by layer process, we can make ceramic parts that are, again, fully self-supported and they are functional parts. And after they are printed, this time they actually need to be sintered, cured in an oven, like you make a pottery, right?
Right.
You make the green body and then you have to put it in the oven and it needs to cure. We do the exact same process, just at slightly higher temperatures. And then we can actually do the same thing. We can use it as functional parts. So we had been dabbling with these different approaches in the last number of years. And then, honestly, COVID hit. And when COVID hit, there was a illusion. We also had the same illusion that there was a shortage of ventilators. We all remember that, right? We all thought that there's going
Right.
to be, at the end, this wasn't really the issue at all. But basically, in our lab, we're a turbomachinery lab. And when the only tool you've got is a hammer, every problem is a nail. So we thought, well, the ventilator, this is just a turbo machine. We just need to find a way to 3D print, fully 3D print ventilators in one go. And we had a number of projects on this, and we actually had some plastic prints of emergency ventilators that function. But at the end of the day, the medical business is not really where the turbo machinery shines. So once the COVID crisis kind of passed, we refocused our technological knowledge in this field back to our gas turbine basis.
Okay.
And leveraged the exact same concepts of design for additive manufacturing and the same concepts of self-supported 3D printed structures back into the gas turbine domain. So what you're seeing here on my table is a fully 3D printed engine. At the bottom is the base plate. This is actually going into the printer. And just to be able to show you, I have sliced the middle of this engine. Normally, you wouldn't be able to see it. I have sliced the middle of this engine. And what you're seeing here is the cut that you have from this Inconel print of an engine with the self-supported rotor rotating structure in the middle and the self-supported stationary housing that's around it. And everything is manufactured in one go in a single uninterrupted process without any assembly.
Incredible.
So now we are coming to a point where we have done the manufacturing technology demonstrator. This is it. And we have some spinning parts already. We have went back to the design board and reintroduced some of the limitations for manufacturing into our turbomachinery parts. So we have redesigned this engine. And now we are hoping that in this upcoming year, we'll actually have a self-fulfilling cycle, meaning there will be fuel coming in, exhaust thrust, and everything else involved. So it's very, very exciting time for us in the lab.
Wow, that's amazing. So you're really going to revolutionize so many things. It's absolutely incredible to see all of that. And it sounds to me like you at this point with the various ceramics, the Inconel, et cetera, you don't have to wait for somebody to manufacture this outside of your lab, you can do it all in the lab at this point, which means you can move your process faster along.
Yeah, I mean, we have a lot of this is what people call vertical integration, right? So
Yeah.
you basically have everything in one place that you're going through it. In theory, you're right, but in practice, the volume of our demand internally is so large that we are putting out manufacturing POs to the outside in the orders of hundreds of thousands of dollars every year. So in reality, for precise things, or in reality for R&D needs, we are doing everything pretty much in-house, because then you can really incorporate the needs that you have into the manufacturing process, iterate and all that. But sometimes, just like everyone else, we just need to have a bracket that needs made, and we need to have like something basically, I don't know, a screw and a gear and a worm, whatever, and a standard part, right? I mean, this is much better just to outsource it and get it done somewhere else, and
Right.
try to keep your focus on the R&D.
On the research. Right. And so when you talk about those hundreds of thousands of dollars output, where does that money come from?
So in our lab, basically, we have quite a bit of grants from national entities. So we have grants from Ministry of Energy, Ministry of Defense, Israeli Science Foundation, as well as Innovation Authority in Israel, as well as some of the industries here. So we have some collaborations with Rafael, Bet Shemesh Engines, Elbit, basically all the main players. In addition to this, internationally, we have ongoing activity with US Army, with NATO, with Max Planck Society in Germany, European Research Council, US Air Force. I need to think what else. So pretty much anything and everything that moves and wants to collaborate with us, we have ongoing activities with.
So you
That's
not
it.
only get to be an R&D guy, but you also get to be a fundraiser, so to speak.
I mean, it's a little different, right? So in reality, I think to be a fundraiser on a university level, or a fundraiser in an entity institution level, is a much tougher job, because for me, the only thing that I need to actually portray is, I think, the good work the students and the staff here are doing,
Right.
and I believe in it, and I'm a part of it. I physically sit in the lab every day, all day. I'm a part of that environment, right? For
Sure.
me, it comes natural to me to be able to show that. I think to be able to do fundraising in an institution level, it's a much tougher job, because although we are one community, it's very much more difficult, I think, to be able to convey whatever is happening inside the organization to the outside world, right? When you're
And
actually sitting on the other side.
as a fundraiser, I can tell you one of the challenges we all face here in the US is there's so many hundreds of things going on at the Technion. How do you talk? First of all, how do you talk about it? And second of all, we're not scientists, so we don't understand everything that's going on. So,
And the interest of everyone is interested in something else, right? Because
right,
it's an institution that has, it's basically an organization that has many different fields and excellent researchers in all these fields.
right,
And how do
right,
you kind of package that in a certain way? It's a very different thing. For me, I only need to say something about gas turbines that I think something about, and we do some unique things, and that's it.
right. So I've asked you about the things that we are well aware of. Tell me about some things that I may not be aware of to ask you about that are exciting to you that you would like our audience to hear about.
Yeah, this is so in addition to basically the usual 10 to 12 projects that we have going on in the lab, recently we have joined a collaboration with Boeing in order to be able to build a specialized combustor test rig in order to qualify sustainable aviation fuels. So this is a collaboration that I have with two other faculty members from our department, Danny Michaels and Joe Lefkowitz. And in addition to them, of course, we're also working with the chemical engineering department here in Technion. And our goal is together as one entity to be able to design particular sustainable aviation fuels, form them, make them, and then to be able to test and qualify them in-house in Israel in Technion. And the aspect that we are involved in from the aerospace engineering side, we are not really chemists, but we know how to build facilities and infrastructure in order to be able to qualify these fuels. And this is an effort that Boeing is funding, which is very exciting for us. And their mission is to be able to make more green fuels and be able to have better supply chain of fuels and all that. But I think the end goal, the reason that I'm actually involved, and the end goal for Israel is more than just environmentally friendly needs. Israel, one of the things that it lacks is the natural resources in order to be able to make its own jet A fuels, right? Aviation fuels. So in terms of energy independence, it's very important for Israel to be able to have the capacity to be able to create its own fuel, essentially from thin air,
Yeah.
and to be able to qualify it for flight, whether it's for military and civilian needs.
Interesting. So, and I want to point out to our audience that's listening in, as Benny has talked, you've probably noticed threads throughout all of this that a lot of the work that he's doing is for the betterment of Israel. And quite frankly, in the Technion's mission, the research and the focus of research all the time is about not only inventing incredible things like what Benny's talking about today, but it's also for the betterment of Israel. And when you think of the MITs and the Harvards and the Stanfords, it's for the benefit of those universities and their statistics, although what's coming out of it hopefully changes the world. What we're doing here is a little bit different, and you'll never find it anywhere else in the world that an institution's main goal or one of its main goals is to benefit the country that it resides in.
Yeah, 100%, 100%. And I mean, I always say, especially in our department, we always have two things that we keep in mind, right? One thing is about supporting the security needs of the country, so that's more the defense side, and on the other side is the technological superiority of the country, which is the powerhouse for the growth, economic growth that we are actually seeing, right? So I think we need to keep in mind both of them, and I think Technion as a whole has been the driver of the technological growth in the country basically ever since its establishment.
Yeah. So let's do a shift. And before we do so, I want to remind everybody in the audience, if you have any questions for Benny, please feel free to type them in the chat. We're going to wrap up soon, so I'm not seeing anything in there now. Now I'm going to shift and I'm going to ask you to help me out. So, as a fundraiser in the United States, trying to raise funds for the Technion, it's not like the University of Michigan or Case Western Reserve where I can walk somebody on campus and show them what they're doing. Yeah. So if you can speak to why it is so important for the American donor to not only give to what you guys are doing there to help with infrastructure and research and postdocs and all of that, but also why it's so important for the country as well, what this money is doing for your research, which then helps the country.
Yeah, this is an excellent point. So in times of crisis, like we saw in the last year and a half, it makes sense that people have natural tendencies, and they should, to support the imminent needs of whether it's IDF or something else, or I don't know, it could be even some other, let's say, a charity-based organization in the state of Israel. But supporting Technion is actually the path for supporting the future of Israel. Maybe it's not today. So because Technion is truly the driver that enables innovation in the state of Israel and that enables progress, enables technological superiority among other nations. And this is actually the path where there's a trickle down of the technologies. A lot of the technologies that we develop, and not only in my lab, in all the other labs as well, they get commercialized and they get transitioned to other industries in the state of Israel, whether it's for defense or energy or completely unrelated medicine, algorithms, computer science, electrical engineering, and all that, right? So they're all being transitioned to the industry, which then in turn drive the economy of Israel forward. So I think in terms of support, the thing that people need to keep in mind is when they're supporting Technion, they are supporting the next 20 to 50 years of Israel, not only today. And I think that's actually one factor that's very different than it is for many other organizations, because we all care about a long-lasting legacy. There's no longer lasting and more permanent legacy that one can contribute to than Technion. And by the way, that's why I'm in Technion. I mean, I've chosen to be here. I'm essentially putting my entire life here, although I'm not from here, right? Because I want to be contributing to that end goal, to that mission, to that idea.
Yeah. Well, and I think as those of us living out in the diaspora, and I am like you, I have been a Zionist since I was a young boy. You know, I have family that was in the Holocaust. Seeing what we've seen around the world today, as Jews, as individuals who believe in the state of Israel, we need a place to call home, and it always has to be there because you never know what's going to happen in the world. So. Listen, I can't thank you enough for doing this. This was a wonderful conversation, and I know our people truly enjoyed it. I'm not seeing any questions, so you know we're gonna let you go in a few minutes. I do want to put it out there to everybody that our next series, which is coming up on March 27th, we are going to be talking with Professor Nabi Ayub. Who is harnessing DNA and repair for targeted cancer therapy. And for all of us around the world, I don't think I know anybody who hasn't been touched by cancer, whether it's a family member or a good friend or things along those lines. And his research is focusing on something that could change the face of how we deal with cancer. So I hope you'll put it down on your calendars for March 27th and you'll join us again. I'm going to throw it out there one more time. If anybody has any questions, please feel free to throw it in the chat. And Benny, thank you so much. I can't wait to see you in the States at some point again.
Yeah, I hope so as well.
So
thank
great.
you very much for having me.
Okay. So this was great. And we will talk with you soon.
All right, perfect.
All right. Be well. Stay safe.
All right. Thank you guys. Bye-bye.
Bye-bye.